Okay, over here to the right, we have a diagram depicting the situation. The ranch is up here 4 miles from the perpendicular distance to the highway is 4 miles. So this is the highway. It's 9 miles from here to the city. He wants to build a dirt road from his ranch to join the highway, going at 20 miles per hour there. And from here, he's able to go 55 miles per hour. So the question is, where do we join the highway? So let's call this distance right here X. And that means from the point where he joins to the city is 9 minus X. So what we're doing is finding expressions for distances right now. The length of this green dashed line is based on the Pythagorean theorem. X squared plus 4 squared equals this distance squared. So this distance is the square root of x squared plus 16. So we've got expressions for the 3 distances that we're interested in. But we need time. We want to know what is the minimum, where does he join the highway to get to the city in the minimum amount of time? He could just drive this way, perpendicular, 4 miles at 20 miles per hour and 9 miles at 55 miles per hour. Or he could try to build the dirt road straight to the city. Good luck on that one. The question is, what are expressions for time? So the time, remember, distance equals rate times time. So time is equal to distance divided by rate. So for this green dashed line, or the length of the dirt road, the time he spends on that dirt road, I'll call it t sub 1, is equal to the distance divided by the rate, 20 miles per hour. And how long will he spend traveling straight along the highway? It'll be the distance, 9 minus x, divided by 55, distance divided by rate. This is time 2. So if we add those times together, we will have an expression for the time that he spends traveling to the city. So we could call that the time function t of x equals the square root of x squared plus 16, which when you're going to find the derivative, you'll write as x squared plus 16 to the 1/2, plus the time he spends driving straight along the highway. Now, how do we find the value of x that minimizes that time? We find t prime of x. I'll let you figure that out. What do we do with that first derivative? Well, we find the critical numbers. We set t prime of x equal to 0 and solve for x. We have to take steps to prove that that x value is generating a minimum. But that'll either be the first derivative test or the second derivative test. Probably the first derivative test would be the way to go. So I'm going to leave this problem at that point, but I'll also post a link to a Desmos graph that shows what the answer is, and hopefully you can take a look at that after you've worked out this problem. There you go. Hope that helped. If you have any questions, post a comment.